Hi everyone, in this video we will solve problem 2.4 from the book Applied Thermodynamics, McConkey and Eastop. Here is statement of the problem 4 from chapter 2. 0.05 kg of steam at 15 bar is contained in a rigid vessel of volume 0.0076 meter cube. What is the temperatures of the steam? If the vessel is cooled, at what temperatures will the steam be just dry saturated? Cooling is continued until the pressure in the vessel is 11 bar. Calculate final dryness fraction of the steam and the heat rejected between the initial and the final state. First, I am writing the data that is provided in the statement. Mass of the steam 0.05 kg, pressure P1 of the initial state 15 bar. Information about the steam is not given, whether it is superheated, wet gas in the final state, it is in the wet state, but in initially we don't know whether it is superheated or dry saturated vapors. So we will first calculate that. The volume of the rigid vessel is 0.0076 meter. We need to calculate the temperature of the steam at the initial state, that is T. Let's say if the vessel is cooled, at what temperature will the steam just dry saturated? So T as saturated temperatures need to calculate at this pressure 15 bar from the steam saturated steam table. And then cooling is continue until the pressures in the vessels drops to 11 bar. T2 pressure is 11 bar and the steam is then reached to wet region, means the steam is in wet condition. This is the vessel, rigid vessel. Inside it there is a steam whose mass is 0.05 kg. Initially the steam is condition is P1 15 bar, and then the final conditions it reached, the steam is in the wet regions and the pressure P2 is 11 bar. Steam is in the wet region. When the steam is in the wet region and pressure falls to 11 bar, we need to calculate the dryness fractions of the final state and the heat rejection that is taken place between these two final state 1 and 2. That is our requirement. So almost, since it said that the vessel is in the rigid conditions, so the specific volume at the initial state must be same the specific volume of the final state. Specific volume is equal to the total volume divided by mass that is present in the volume. So what is volume? That is 0.0076 divided by mass of steam that is present inside it, 0.05 kg. After divisions you will get its value, that is 0.152 meter cube per kg. Now from the saturated steam table at 15 bar, look at the saturated specific volume, that is 0.1317. The Vg value is 0.1317 meter cube per kg. It's obvious that the Vg value is less than the specific volume that is provided. The basis of that we can conclude that our initial state point is in the superheated region. State 1 is in the superheated region. So all the corresponding values you will see from the superheated steam table, not from the saturated steam table. So that's why I have taken the portion of the superheated steam table. 15 bar pressures and specific volume of 0.152 and the corresponding temperatures is 50 centigrade, that is T1 and it is 250 centigrade. So the first requirements of this statement has been calculated and is 250 centigrade. That is our answer, first answer. Next is to find the vessel is cooled at one temperature, the steam is just dry saturated. It's very easy. The steam is dry saturated and its specific volume is given, then we will see its value from the saturated steam table and the corresponding specific volume we can get the saturated temperatures. Specific volume is fixed throughout the process because it is the vessel is in the rigid conditions and it is 0.152 meter cube per kg. Now look at this 0.152 in the saturated steam table. You didn't see its value on the saturated steam table. For that purpose, we will do interplotting. Find the saturated TS temperatures for this specific volume. The TS value will be equal to now these values you have taken from the upper and lower value from this saturated steam table, of the saturated steam table, and put in this interplotting formula. You will get the TS value. Let me give you the values, what kind of value you will get from the saturated steam table. This is T upper, this is T lower, this is specific volume upper, this is specific volume lower. Now put that in this interplotting formula. Actual specific volume at which we are finding the TS value is 0.152 meter cube per kg. Now put all these values in this interplotting formula. The things are very easy. Just put it in the formula. Let me put it. After solving this on the calculators, you will get the TS value at which the steam is dry saturated, that you will get almost 191.2 centigrade. Now come to the third conditions of the problem statement, where it reached the final state where the pressure drops to 11 bar and the steam is in the wet region. For that we need to find the dryness fractions and the heat rejections taking place between the final and initials. In the final state condition, the pressure to 11 bar and the steam is in the wet conditions. At 11 bar, specific volume of saturated steam is 0.1774 meter cube per kg, and we already calculated that the volume of the vessel is rigid and it is 0.152 meter cube per kg. Dryness fraction will be equal to actual volume divided by volume, and the steam is dry saturated. After solving, you will get the dryness fraction value is 0.857. Next we need to find the specific internal energy at the final state. For that, we take some value from the saturated steam table. That is UF at 11 bar, it is 780, and UG value, that is 2586 kilojoule per kg. The final U1 value will be equal to 1 minus X into UF plus X into UG value. Now put all these values in these equations to get the final. Here it is U2, sorry, not U1, thus we are finding for the final state. After solving this, you will get the final specific internal energy U2, that is 2327.7 kilojoule per kg. Then U2 value, the specific internal energy of the final state has been calculated. We need to calculate the specific internal energies. So far we have calculated the specific internal energy of the final state. Then we find the heat rejection between two states. We need to find the specific internal energy of the initial state U1. At initial state, the steam pressure was 15 bar and the steam specific volume, and also we have concluded that initially the steam superheated region. Then from the superheated steam table, at this 15 bar pressure and specific volume 1.52 meter cube per kg, you can observe that 15 bar at pressure 15 bar and specific volume 0.152 meter cube per kg, specific Internal energy is 2697 kilojoule per kg. U1 is equal to 2697 kilojoule per kg. Since there is no work done in the steam because the steam are vessel in the rigid condition. So the heat rejection is equal to mass times change in specific internal energy. What is the mass? That is 0.05. It is U2 is 2327.7 minus U1, it is 2697. After multiplications and subtractions, you will get the heat rejections from these rigid vessels. That is 18.5 kilojoule. This is all final answer. Negative sign mean that heat rejections from these rigid vessels has been taken place. I hope you understand. If you're still in confusion, you can ask in the comment section. Subscribe my channel if you haven't subscribed, and also share with your friends and colleagues for supporting me.